Right, hello again. Now, there was something I wanted to say on the last video with regard to that Turlin antenna, and I couldn't because I'd run out of time. This camera records in blocks of 20 minutes and then it will just stop whether I want it to or not. I haven't figured out yet how to change that. I'll have to fish the instructions out of the bin, as they say, and see if I can change the recording time to something that doesn't automatically cut me off when it feels like it. What I was going to say was, well, there's two things actually. One is you can't use this type of antenna on a Reliant Robin or a Scimitar or a car that does not have a metal body. It just won't radiate, so you'll be wasting your time. Not too many Reliant Robins in Australia. In fact, I don't remember seeing a Reliant Robin on a dirt road, come to think of it. But anyway, if you're new to radio, or you're new to amateur radio, you may find it a little confusing that when I was testing this antenna, that I measured the inner of the SO239 to the outer of the SO239 and saw a short and said, yes, that's what I expect to see, because you might be thinking, why didn't he see 50 ohms? And the answer to that, of course, is that when you're using a multimeter to measure resistance, you're actually applying a DC voltage, and the DC voltage will just go through there. It will run through a few turns of a coil, and it will present no resistance at all. That same few turns in a coil can present a reasonable impedance to high frequency AC, which is what RF is. So the RF will see it as 50 ohms. The DC measurement will be 0. The problem would arise if it was actually open circuit with this plugged in. If that was plugged in and it was open circuit from the inner to the outer, then the coil inside the antenna would have been open circuit. I hope that makes sense. Okay, what might make it a little clearer is I'm going to put the board. Where did I put the board? Right, now I'm not going to try and draw this upside down because it's 20 past 11 at night and I'm getting tired. I want to go to bed. I've got to be up at 6:15. As no one's buying my novel, I have to work for a living. So you might want to consider buying a few million copies. Right, okay, now what's going on inside the antenna is you have the stainless steel whip and you have the coil section. Now I won't draw a line there because it will look like a capacitor, and it isn't a capacitor. It's the bottom of that coil there is not connected to the actual sprung loaded base. So that bottom bit there is the sprung loaded base, and that's connected to the chassis of the car. Now the SO239 socket, which is on the side of that sprung base, goes from the bottom of the coil. No, it doesn't. Wakey, wakey, Steve. I know you just said it was late. Late. The ground of the SO239, the outer of the SO239, goes to the sprung loaded base and to the chassis of the car. Okay. So, and the inner will go to a few turns up this coil. So let's say it goes there onto that point there. So when you measure it with the ground fly lead off, because the ground fly lead is also connected to that point there. I'll draw that just as an arrowhead. So the ground fly lead, I'll try and keep the glare off it. So the ground fly lead is connected to the sprung loaded base, and so is the outer of the SO239 socket. So without this plugged into the G, that would be the G connector on the antenna. Without this fly lead plugged into the G point, the measurement from the outer to the inner will be open circuit. Once you put that lead, that fly lead with the green plug into the G socket on the antenna, then the current from your multimeter will go along the outer, through the fly lead, up here, through a few turns of coil, then back down to the centre. So it will look like a short. It'll look like, it'll be such a low resistance you probably won't see anything at all. It'll just look like a dead short. But that's how it's supposed to look. The other bit that I did was this big long coil here that goes up to the radiating whip part has got a lot of taps on it. So it's going to have a tap for 80, have a tap for, I won't draw them all in because that's got quite a lot on it, but it's going to have 40, a tap for 40, that's another socket there for 40, pardon me, another one for 20, and another one for 10 meters. Okay, so you can see there that these are the tap connections on the whip. So you've got the 80 meter one, the 40 meter one, the 20 meter one, the 10 meter one, and as it's getting towards the actual radiating element, you're using less and less coil. You know, the lower the frequency, the more coil you've got on there. And when it connected as I had it connected, so this 80 meter tap is also, remember, the common point for the Wander lead, but I had it connected basically like that. So you can see that for 40 meters we're not using that part of the coil. That part of the coil's short circuit with the Wander lead. And what I was doing was I measured from the center point through the coil up through this Wander lead through to that banana plug, which showed me the connections there were all good, and then I measured from the knurled nut, which is there, that locks the whip in place. I measured from there, I plugged that banana plug in, I took that one out, and I measured all the way through there through to the other banana plug, which told me that was okay. So I know this antenna is continuous all the way through. I know that it's not short across here because without the fly lead on, that measured open circuit, and then when I plugged it in, measured short, which is exactly what I expected to see. So I would say that just with those couple of simple tests, I can say my Turlin antenna looks pretty healthy. Certainly healthy enough to bother with putting on the car and tuning. Okay, so that's the 5 or 6 minutes worth that I couldn't squeeze onto the previous recording. I hope you found that useful or interesting, or both. And as always, many thanks for watching. I'll catch you next time.